All right, yesterday we talked about adding liked fractions. Today in lesson 3 and 4, we are going to talk about subtracting like fractions. We're going to do it in a very similar style to how we did it yesterday, where first we're going to talk about it using a model, and then we will do it using algorithm, which is just doing the math with it. Then we'll do independent practice, and then you will be on your own for the homework. All right, so let's jump into lesson 3. Hands-on, use models to subtract like fractions. Read up here. We always read up here because it tells us a little bit about what we're going to be doing. You can use models to subtract like fractions. Think of subtracting fractions as separating parts that refer to the same whole. Build it. Braden used 4/5 of his coins in the first 2 levels of a video game. He used 1/5 of his coins in the first level. What fraction of his coins did he use in the second level? So we need to take 4/5 and subtract 1/5 from it. So first we need to draw our model. We need to draw our fraction bar, which they did, and they colored in 4 pieces. They divided it into fifths and colored in 4 of them to show 4/5. Then they took away 1/5 because we are subtracting. Now we need to count the total of 1/5 tiles that are left. 1, 2, 3. There are 3 1/5 fraction tiles left. 4/5 minus 1/5 equals 3/5. So Braden used 3/5 of his coins in the second level. When you are subtracting like fractions, you can use addition to check. So you're going to take your answer, which we got 3/5, and add it to 1/5. Yesterday we talked about adding like fractions, so we know how to do this. You keep the denominator the same, and then you just add the numerators. 3 plus 1 is 4. 4/5 is what we started with, so we are good to go. Let's do another one. Find 7/8 minus 3/8. So step 1, you need to model 7/8. So they do a fraction bar and divided it into eighths and colored in 7 of them. See how there is 1 that is not colored in? If we colored that one in, we'd have 8/8, and we only need 7/8. So we only colored in 7. The numerator tells us how many pieces we color in, while the denominator tells us how many pieces there are overall. Notice that 7/8 is the sum of 7 unit fractions of 1/8. So if you took 1/8 and added it 7 times, you would get 7/8. Now for step 2, we need to subtract 3/8. So we're going to cross out 3 of our fraction blocks, or our fraction tiles. Notice that 3/8 is the sum of 3 unit fractions of 1/8. So 3/8 is equal to 1/8 plus 1/8 plus 1/8. Count the remaining 1/8 tiles. We have 1, 2, 3, 4 left. There are 4 remaining 1/8 tiles. So 7/8 minus 3/8 is 4/8. Now 4/8 can be simplified. If I'm finding their greatest common factor to simplify, 4 is 1, 2, and 4. 8 is 1, 2, 4, and 8. Their greatest common factor is 4, so they divided the numerator and the denominator by 4. 4 divided by 4 is 1. Any number divided by itself is 1. And 8 divided by 4 is 2. So 7/8 minus 3/8 is 1/2. Now, when you check this using addition, you want to use the answer that is not simplified, because if I put in 1/2 here, my denominators are different. All right, when we add like fractions, our denominators need to be the same. So I don't want to use the 1/2. I want to use my 4/8. Now we leave the denominator the same, 8 stays 8, and we add 4 plus 3 to get 7/8, which is what we started with up here, so we are good to go. Let's practice a couple using a model. Model the difference using fraction tiles, then subtract. So for number 2, I'm taking 4/6 minus 3/6. So I need to draw my fraction bar. I'm actually going to come down here, I think, and make some room down here. There we go. There we go. So now I can draw and have more space. All right, so I need to draw a fraction bar, and I need to cut it into how many pieces? Think about that. How many pieces do I need to cut this fraction bar into? If you said 6, you are right. Do you know why 6? Because our denominator is 6. And our denominator tells us how many pieces we need overall. Now, I'm going to use 2 different colors. First, I'm going to start with my 4/6. So I'm going to color in 4 pieces because my numerator tells me how many are colored in. And I need to take away 3 of them because I need to take away 3/6. All right, this is 1/6, 1/6, 1/6, and 1/6. Altogether, it equals 4/6. But if I take away 3/6, I cross out 3 of the 1/6 pieces. Now I need to count how many are left. Just 1/6. So my answer to number 2 is 1/6. All right, let's do another one. Let's erase all this so I have plenty of room to draw. All right, number 3, 9/12 minus 4/12. So I need to draw a fraction bar. I'm going to make this one pretty big because I need to cut it into how many pieces? Hopefully you said 12 because our denominator tells us how many pieces we need overall. Now, how many pieces am I going to color in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. How many pieces am I going to color in at first? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, how many am I going to take away? 4. 1, 2, 3, 4. I colored in 9 out of my 12 pieces, and I took away 4 of those 9/12. So how many pieces am I left with? 1, 2, 3, 4, 5. And remember, each piece is a 12th, so I'm left with 5/12. Hopefully you are doing these pages with me and practicing. Remember, these are all the pages we do together. So the answer to this is 5/12. All right, try and do 4 and 5 on your own. Pause the video, do 4 and 5 on your own, and then we are going to jump into doing subtracting like fractions using algorithm. All right, we just worked on subtracting like fractions using models. Now we are moving on to lesson 4, which is subtracting like fractions using straight algorithm, using just math, no models. So let's read up here. Think of subtracting like fractions as separating parts that refer to the same whole. To subtract like fractions, subtract the numerators and keep the same denominator. So it is almost identical to adding like fractions, where we keep the denominator the same and only work with the numerator, except instead of adding the numerator, we are now subtracting the numerator. All right, example 1, make sure you are doing these pages with me. Liliana jogged 5/8 of a mile on Monday and 3/8 of a mile on Tuesday. How much farther did she jog on Monday? So we are finding 5/8 minus 3/8. So step 1, subtract the numerators. Keep the same denominator. So we have 5/8 minus 3/8. We keep the 8 and we subtract 5 minus 3. Over here they have a model showing you what they did just as a reference, but remember, we are just using algorithm. We are just using the math for this. Now you need to write the difference in simplest form. 2/8 have a greatest common factor of 2. So when you divide 2 by 2, you get left with 1, and 8 divided by 2 is 4. So Liliana jogged 1/4 mile farther on Monday. Super easy. You just need to subtract the numerators, and we all know how to subtract. All right, example 2. Find 7/10 minus 5/10. You can also use a number line to subtract like fractions. Count back 5 groups of 1/10 to remove 5/10 from 7/10. So on their number line over here, they divided their number line into 10 pieces to make 10/10 or 1 whole, and they marked 7/10. Now they need to subtract 5/10 from that, so they're going to make 5 jumps. 1, 2, 3, 4, 5. And they land on 2/10. Well, 2/10 can be simplified. If I list the factors of 2, I have 1 and 2. And if I list the factors of 10, I have 1, 2, 5, and 10. So what is their greatest common factor? 2, and that's what we're going to divide by. So 2 divided by 2 is 1. Remember, any number divided by itself is 1. And 10 divided by 2 is 5. So our final answer is 1/5. So 7/10 minus 5/10 is 1/5. Guided practice. Find each difference, write in simplest form. All right, remember, if it doesn't say to write it in simplest form, you can just leave it. But since it does say write it in its simplest form, you must do both steps or it is not considered correct. All right, so number 1, 6/8 minus 3/8. Well, I know I keep the denominator the same, so I'm going to go ahead and put my 8. Now, all I need to do is subtract my numerators. So 6 minus 3. If I have 6 and I take away 3, I'm left with 3. Now we need to write it in its simplest form. Well, 3 is a prime number, so I know that the only factors of 3 are 1 and 3. And 1 is the only common factor that 3 and 8 have, so it's already in its simplest form. 1 and 3, 1, 2, 4, and 8. The only common factor they have is 1, and if their only common factor is 1, then it's already in its simplest form and there's nothing else we can do. Let's look at number 2. 11/12 minus 5/12. Well, we keep our denominator the same, and now we just subtract our numerator. 11 minus 5. If I wanted to draw my number line, I could divide it into 12 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops. Let me try again. And each piece is 1/12, 2/12, 3/12, 4, 5, 6, 7, 8, 9, 10, 11, and then 12/12 is also 1. So I'm going to mark 11/12 on here, and I'm going to jump back 5. 1, 2, 3, 4, 5. And what do I land on? 6/12. Well, let's see if I can simplify this. I'll write it in black. My factors of 6 are 1, 2, 3, and 6. My factors of 12 are 1, 2, 3, 4, 6, and 12. So what's the highest number that they have in common? 6, which is our greatest common factor. So I need to divide 6/12 divided by 6 on top and 6 on bottom. 6 divided by 6, any number divided by itself is always 1. And 12 divided by 6 is 2. So our final answer for number 2 should be 1/2. Now, head on down to the independent practice in your packet, work on this, and when we come back, we will review it. You can skip down here if you want, just focus on these ones up here. All right, since this is 2 lessons in one, I'll make it a little easier, and you can just focus on 3 through 11. So go ahead and give that a shot, and then come back, and we will go over some of them. All right, we are going over some of our independent practice problems. I'm only going to go over a couple of them, and then you can check the rest of them with the answer key that is on Canvas. All right, we are going to do 3, 6, and 9. Let's start with number 3, 7/8 minus 2/8. Well, I keep the numerator the same, or I keep the denominator the same, sorry. If we were in class, you would have corrected me, I know it. And then I just subtract my numerator. 7 minus 2 is 5. Well, I know that 5 is a prime number, which means its only factors are 1 and 5. And since 5 is not a factor of 8, 1 is their only common factor, which means it's already written in simplest form, so I do not need to do anything with it. Okay, the directions say find each difference and write in simplest form, which means if I don't write it in simplest form, it is not correct. Okay, but for number 3, there is no way we can simplify that fraction, so it just stays 5/8. 2/3 minus 1/3 for number 6. We keep our denominator and subtract our numerator. 2 minus 1 is 1. Number 9, keep our denominator and subtract our numerator. 9 minus 5 is 4. Well, I know that these numbers have some common factors. So, what are our factors of 4? 1, 2, and 4. What are our factors of 12? 1, 2, 3, 4, 6, and 12. So what is their greatest common factor? What's the highest number they have in common? 4. So I need to take 4/12 divided by 4 on top and 4 on bottom. Well, 4 divided by 4, any number divided by itself is 1. And 12 divided by 4 is 3. So your final answer for number 9 is 1/3. All right, go ahead and check the rest of your answers to the independent practice with the answer key on Canvas. And then you are going to complete these pages for homework, lesson 4, page 583 and 584. The homework answer key will be posted under tomorrow's module, so you cannot view that until tomorrow. So make sure you are giving the homework a shot, and I will see you tomorrow for our next lessons.